So, geometric sequences and series. Little sequences. These ones are a little bit different. Geometric sequences are a little bit different than arithmetic. They still follow a pattern, but in this case, instead of adding or subtracting a number every time or a common difference, we multiply by a specific number every time, or we call that a common ratio. Okay, so if you look at this sequence from 5 to 10, you might first start saying, oh, 5 to 10, I added 5. But then from 10 to 20, you don't add 5 anymore. Okay, so you know it's not arithmetic. Well, how else could you get from 5 to 10? Well, you could multiply by 2. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. Ah, there it is, repetitive multiplication. We're repetitively multiplying by 2. So, here we go. We're going to, again, show you how to write the recursive and explicit equation for a geometric. Recursive looks just like, for geometric, looks just like arithmetic. You state where you begin. We started the first term was 5 in our sequence. Then we say f of n is f of n minus 1, so that's the previous term. And in this case, then, we multiply by 2. Again, we could use subscript notation. Looks like basically the same thing. All right, explicit. Explicit's a little bit different here. Explicit's a little bit different. Notice here on the outside, we still have our first term. On the inside of parentheses, we have 2 because we're repetitively multiplying. Remember in mathematics that repetitive multiplication is an exponent. So if repetitive multiplication is an exponent, then this n minus 1 has got to be in the exponent. Now notice we do n minus 1 here, which is exactly the same thing we used up here with arithmetic. So we could write it in subscript notation, a sub n equals 5 times 2 to the n minus 1. All right, so here we go. Let's practice it out and try it. Write a recursive equation for the following sequence. The first thing you have to do is determine what's going on. Is it arithmetic or is it geometric? Well, you might first start thinking it's arithmetic. I mean, check it out. To get from 6 to 3, you would minus 3. 3 minus 3, though, the next term should be 0, and it's not. So I'm not subtracting 3 every time. Is there another way to get from 6 to 3? And you might say, oh, divide by 2. Correct. But we want to do repetitive multiplication, so instead of dividing by 2, what if we multiplied by a half? What's 3 times a half? Well, that's 1.5. What's 1.5 times a half? That's 0.75. Aha! There it is, repetitively multiplying by a half. So the recursive says, okay, where did we begin? We began at 6. That was our first term, was 6, right there. Then we'd say f of n equals the previous term, f of n minus 1, times a half. To do a subscript notation, you would just write a sub 1 equals 6. Then you'd write a sub n equals a sub n minus 1 times a half. That's simple. An explicit equation. Sure, let's write an explicit equation for this one here. How do you get from negative 5 to negative 15? First, you might think, I'll subtract 10. But then if I subtract 10 again, I should be a negative 25, and I'm not. So there's got to be another way. Oh, well, if I multiply by 3, I can get there. Negative 15 times 3 is negative 40. Okay, yeah, multiply by 3 it is. So the explicit equation would look like this. F of n equals, where our first term, negative 5, the thing that we're repetitively multiplying by goes inside. It's called known as our common ratio. Goes inside, and then it's to the n minus 1. You're done. That's it. Woohoo! Easy. Easy. Okay, find the first 3 terms of the sequence. Okay, sure. Well, that means we want to find a sub 1, a sub 2, and a sub 3. Recognize what kind of equation they give you. A sub n equals 2 times 3 to the n minus 1. Do you see an a sub n minus 1 or anything like that? No. So this is not a recursive. This is an explicit equation, which means a sub 1 is 2. And the common ratio is 3, which means you repetitively multiply by 3. 2 times 3 is 6. 6 times 3 is 18. If you don't want to think of it that way, you still could plug a 1 in. 1 minus 1 is 0. 3 to the 0 is 1. 1 times 2 is 2. Plug 2 in. 2 minus 1 is 1. 3 to the 1 is 3. 3 times 2 is 6. Plug a 3 in. 3 minus 1 is 2. 3 squared is 9. 9 times 2 is 18. Either way works for me. Okay, look at this next one here. Ready? find the first three terms of the sequence. A sub 1 equals 4. So, okay, they already give me a sub 1. A sub 1 equals 4. And then I want a sub 2. And I want a sub 3. Well, it says that I need to take negative 3 times a sub n minus 1. So, in other words, I need to take negative 3 times 4. That's negative 12. Then take negative 3 times negative 12. That's 36. Notice in this pattern, the numbers will alternate from positive to negative, positive to negative. Okay? Folks, there you go. We're done with geometric. Look for the next video on summation notation. Isn't that fun to say? Summation notation.